the temperature and the density of the atmosphere will change the layers. That means one layer to another layer, there will be different in temperature and density. So look at this figure. It is a structure of the atmosphere. So what do we see here? Five layers we see here. Dear students, this is a troposphere, right? And another one is stratosphere, the second one. Then third is mesosphere. Fourth is thermosphere. And fifth is exosphere. So, dear students, the lower layer of the atmosphere is troposphere, and upper layer of the atmosphere is exosphere. Clear? It means the lower layer is a troposphere. In the sense, troposphere is near to the Earth's surface. Exosphere is far from the Earth's surface. So these are the five layers we find here. Understand? If you observe these, what you call a figure, you will come to know many things. Here, the troposphere. What do we find in troposphere? Parachutes, right? The balloon carrying balloons which are flying in air, aeroplanes, then commercial aircrafts that can move here. Understand? In troposphere, we find a ozone layer which protects us from UV rays, right? Then moving further, you will see that a stratosphere. There, meteoroids are coming which are prevented by stratosphere. So, in detail, we'll discuss all these layers, how they are composed, what is their height, and how much temperature, what happens to the temperature, we'll discuss here. The first one is a troposphere. This is the most important layer, that is a lower layer of the atmosphere. It is 13 kilometers average height and extended roughly 80 kilometers near poles and 18 kilometers at equator. It means an average the height of the troposphere is 13 kilometers. Okay, and its height varies from 8 kilometers to 18 kilometers. At poles, it is 8 kilometers in height and at equator, 18 kilometers thickness. And the thickness of the troposphere is high at equator. Why it is high at equator? Because there the heat is much more, as insolation is high due to vertical fall of sun rays. On equator, sun rays fall vertically, so there it is heated, much more heated area. The air in heated region expands and starts moving to the higher places, so that we find 13 kilometers extension at equator, whereas poles, there the sun rays fall diagonally, so that there the heat is very less due to the less insolation, right? So that there the air in at poles heated very low, so that such a air consisting of air molecules will rise to the higher places, that up to 80 kilometers. That is the reason, because of the heat, there the thickness of the troposphere at equator is 18 kilometers, and at poles it is 8 kilometers thickness. that is a water troposphere. And this troposphere, what you call, consisting of 75 percentage of the total gases of the atmosphere we find here. Understand? The troposphere consists of 75 percentage of the total gases, moisture, dust particles, and whatever the changes takes place in atmosphere. That means sometimes we see it is a pleasant atmosphere, sometimes we see it is bright sunshine, sometimes we see it is covered with clouds, right? So all these type of changes occurs in troposphere only. Hence I call it is the most important layer, right? So all the weather phenomenons, weather phenomenons in the means weather changes, weather fluctuates every moment, right? Sometimes we see it is cloudy, sometimes it is bright sunshine, sometimes it is sultry, right? Sometimes it is a clear sky. So all these are the changes we call weather phenomena. This happens in troposphere, and the temperature in this layer decreases as we move to higher what to call places. Understand? That is called normal lapse rate. That means if you move from the Earth's surface to higher places, you will identify that temperature is decreasing. As temperature decreases moving to higher places, it is called normal lapse rate, right? So why does the temperature decreases? Before going to find this reason, let me give an example that have you identified when you stand on the surface of the earth on the ground floor, you feel it is somewhat warm. When you go to second floor or third floor at the top of the building, you feel it is some cool air touching you. Have you identified this? It means that in the higher places the temperature is low than the lower places, right? Have you identified this? At hilly areas the temperature is low. For example, Darjeeling is there, Ooty is there, these are hill stations. Huh? There the temperature will be less, the atmosphere will be pleasant there to enjoy, right? So why does the temperature is different at the earth surface and moving to higher altitude? For this, already we discussed a reason in 8th class, that is terrestrial radiation. Dear students, you know that earth becomes heat by the process insolation, right? Incoming solar radiation is called insolation. So with the insolation, earth becomes heat. Heated earth releases its heat into the air, that what we call earth radiation or terrestrial radiation. And this terrestrial radiation will heat the layers of the atmosphere. So what is a lower layer? It is a troposphere. So in troposphere, which is near to the earth's surface, gets heated faster, right? So in troposphere, moving from earth's surface to higher places, temperature decreases, and this is called normal lapse rate. Understand? So in troposphere only we see that all the stages of the hydrological cycle occurs here. In the previous class we discussed the condensation, that is water vapor turning to millions of tiny water droplets, right? Evaporation, that is water turning to water vapor. Precipitation, that is deposition of millions of tiny water droplets on the earth's surface in different forms, that is precipitation. Rainfall, cyclones, all these changes we find in troposphere only, right? So this is about troposphere. Understand? It is the lower layer, and it is a 13 kilometers height. An average, it is a 13 kilometers height, and it is 8 kilometers thickness at poles, and 18 kilometers thickness at equator, right? And all the total gases what are present in atmosphere we find in troposphere, right? And here we find all the changes taking place in atmosphere in troposphere only. This is troposphere. Next we move to stratosphere. This is the second layer next to the troposphere. It is extended up to an height of 50 kilometers. How many kilometers? 50 kilometers length, that is 50 kilometers height. After the troposphere we find stratosphere, right? And this is a layer, it is free from the clouds and associated weather phenomena. That means here you will find that the clouds will not appear here. Understand? I'll take you to the what figure 4.2. You understand? Dear students, look at here. Where do you see the clouds? These are the clouds I am showing you. The what to call, this is the cloud we see in troposphere. Can we see these clouds in what to call in stratosphere? No, right? Stratosphere is here. Can we identify any clouds here? No, right? So troposphere we find clouds, whereas in stratosphere it is free from the clouds. And weather phenomena that just now I said, the rainfall, precipitation, condensation, all these also will not occur here. Understand? Making conditions most, it is as it is free from the clouds, it is suitable for jet aircrafts. Dear students, look at this. This is a jet aircraft. So supersonic plane. For supersonic plane, we see that stratosphere is suitable. Understand? So the supersonic planes are jet aircrafts fly in stratosphere, right? Why does not they fly in troposphere? Because troposphere is composed of clouds. Okay, there won't be clear appearance. So these jet planes and supersonic planes fly in a stratosphere. Understand? So here one important feature of this stratosphere is that ozone layer also we find here. Dear students, I'll show you that this is the ozone layer. Where do we see? In stratosphere, right? So ozone layer is very important for us. It prevents the ultraviolet rays, right? It does not allow the ultraviolet rays. And in this layer, temperature increases, moving to higher places. In troposphere, temperature decreases. That is a normal lapse rate. Whereas in stratosphere, the temperature increases as the height changes. Understand? The next layer to the stratosphere is mesosphere. I'll take you to that place. This is mesosphere. It is extended up to an height of 80 kilometers. 80 kilometers length we find mesosphere after the stratosphere, right? And here meteoroids we find, and they burn up as they enter in this layer due to the temperature. And we see here meteoroids will burn. Meteoroids will not enter into the troposphere, as meteoroids come from the space and enters into atmosphere, especially when they reach a mesosphere. There it will burn. So mesosphere is extended up to 80 kilometers thickness. There in this layer, it is meteoroids. Where I'll show you it is in the figure also. Understand, dear students? You can see here it is meteoroids. You will identify it. These are the meteoroids, right? So where do we see the meteoroids? Meteoroids we see in mesosphere, right? It is a mesosphere. You see that here, meteoroids. In mesosphere, we find meteoroids, and those will burn. They will not be allowed into the Earth's surface. As it enters into mesosphere, they will burn. Understand? That is important. Here we see that the temperature decreases with the increasing of height. Understand? In troposphere, temperature increases going to higher places. In stratosphere, temperature increase in troposphere, temperature decreases moving to higher places. In stratosphere, it decreases. Again in mesosphere, it increases. Alternatively, it is there, my dear students. Then next is a thermosphere. This is what to call a layer extended up to 400 kilometers. As the temperature increases very rapidly along with the height in this layer, this is called thermosphere. Thermo is a Greek word which is used to what to call identify the temperature. So here we see that there is a rapid increase in the temperature in thermosphere. It is extended up to 400 kilometers instant. And here it is what to call also called ionosphere, my dear students, because in this layer we find electrically charged particulates, that is particles, electrically charged particles we find there. Those are called ions, and these ions will help in transmitting the radio waves which are what to call transmitted from the earth and reflected back to the earth in another place using these ions, right? When we send signals to the satellite from the earth's surface, those signals will move to the satellite using the ions which are electrically charged in thermosphere. And these ions again what to call reflect that signal what we sent from the what to call earth surface will be reflected to another area. That means these ions are helpful in communicating our signal. So these are electrically charged ions are present in this thermosphere. So it is called ionosphere. Another name also there to this layer, that is ionosphere. Understand? So it is a 400 kilometers thickness. Understand? And after that, there is another layer, that is the topmost layer of the atmosphere, right? That is upper layer. Totally it is at the top, so that it is called upper layer of the atmosphere. What it is? Exosphere. Understand? We are trying to find out the information regarding the exosphere. So far we have not received much. We know very little, because in thermosphere only the temperature is high, so we are unable to identify the exosphere, how it is there, what are the gases composed there, huh? In what way it is useful, what how the changes are taking place in exosphere, right? So all this we are unable to identify, very little only we know about the exosphere. Understand? There the temperature again increases, right? So all these are the five layers. Upper layer is exosphere, that what I stated here, dear students. This is upper layer exosphere, and Next is what lower layer is troposphere, right? This is the what five layers of the atmosphere which are composed in air, right? So it is a thin blanket. Atmosphere is a thin blanket covering the earth surface. It is useful in many ways. Already some of the benefits what we are getting with the atmosphere are discussed, right? So, what you call these five layers consisting atmosphere will appear like a blue layer in the figure it is shown, first figure. I'll take you to that, right? This is the first figure. You see that how it is that thin blue layer, right, covering the water earth. Understand? So between this, what to call black, this is called space, right? And this is my dear student, this is space. Tell you that you I'll tell you that this is space. And don't write, this is space. And this is earth, understand? So here we see between space and earth there is the atmosphere, right? So in atmosphere only we find all these changes are taking place.